Hmm. Here, types of field effect transistors. Okay, FET classification. Okay, mainly broadly classified into JFET and MOSFET. And again, JFET is classified into two types: N-channel JFET, P-channel JFET. Trilak. Okay, okay. Ah, ah, okay. Here, types of field effect transistors. Okay, here broadly classified into two types: JFET and MOSFET. Here JFET is okay junction field effect transistor, and MOSFET is metal oxide semiconductor FET. It is also called as a IGFET. Here IGFET means insulated gate FET. Here ICFET means okay insulated gate field effect transistor. Here MOSFET again classified into okay two types: enhancement type MOSFET, depletion type MOSFET. Again based on the channel, N channel enhancement mode MOSFET, P channel enhancement mode MOSFET. Here depletion MOSFET, N channel D MOSFET, P channel D MOSFET. Okay. In the integrated circuit technology, we will prepare only MOS transistors. Okay. Compared to JFET or BJT. Why we are okay using only MOS transistor is because of small size, and your power consumption also very less. Okay, that's why we are using MOSFET. Primary component in high density VLSI chips such as memories and microprocessors. And JPET finds application especially in analog and RF circuit design, radio frequency circuit design. And here MOSFET again, PMOS, NMOS, okay, and advanced CMOS, complementary MOSFET. Okay, advantages of MOS transistors over conventional transistors means BJT and JFET. Okay, it is a unipolar device. Operation depends on only one type of charge carriers, either electrons or volts. Okay, and this is a voltage control device. FET is normally voltage control device. Here gate voltage controls the output drain current, and here MOS transistors having the very high input impedance, and their source and drain are interchangeable in most low frequency applications. Means if you take any semiconductor bar, okay, if we apply one side drain, remaining side is source, and if you take one side drain, remaining side is source. This is interchangeable. Next, low voltage low current operation is possible because of a lower power consumption, less noisy as compared to BJT. Okay, here BJT also, compared to BJT, here noise is less, and no minority carriers storage. Okay, turn off is faster. Here operating speed is faster. Okay, very small in size, occupies very small space in ICs. Okay, next we will see after this slide. Okay, here notation for the MOS transistors or symbols. Okay, here. symbols. Okay, this is NMOS enhancement mode, MOSFET, and this is depletion mode MOSFET. Here see here somewhat okay here thick side this base is there, gate side. Okay, that indicates the depletion. Here normal okay mass, here only just line. This is an enhancement mode. This is depletion mode. And here PMOS enhancement mode. Here PMOS, here charge carriers are holes. So here we can see the just hole symbol, circle, PMOS. And in NMOS with bulk contact. Okay, here NMOS uh, bulk contact. Generally in the MOS transistors, okay, there are four terminals. Okay, generally in the MOS transistors, either NMOS, PMOS, okay, here total four number of terminals. First one is drain, gate, source. Okay, fourth one is here bulk. Fourth one is bulk. Okay, here bulk. Okay, here just not showing here. First transistor. Okay, here this is also called bulk or substrate connection. Okay, that is in the NMOS transistors. This terminal is always connected to ground. Always connected to ground. But in the PMOS, that is always connected to high voltage. High voltage VDD. VDD. In many okay textbook, this terminal is not they did not show. Okay, that is called bulk or substrate terminal. Here, if you see clearly, okay, different textbooks they will show different notations. Okay, if we see here, first one, this one, NMOS enhancement mode device. Here showing four terminals. Enhancement mode, NMOS, here PMOS. Okay, in the enhancement mode, just dotted lines are there. Okay, that indicate the enhancement mode. Here, okay, inward direction shows the NMOS, outward direction shows the PMOS. And uh, here, if you see here, uh, depletion. Okay, there is no uh, such dotted line, just line. Here, arrow inward indicate the NMOS. Arrow outward indicates the PMOS. PMOS depletion mode transistor. Okay, and here outward indicate the PMOS depletion mode transistor. And you see here C, figure C and F, if you see okay, three terminal NMOS transistors. Okay, here bulk is not missing. This one here, this terminal is okay. This terminal is not missing line. Okay, we can indicate like this also. Three terminal NMOS transistors and here three terminal PMOS. Okay, we can indicate NMOS like this. Here, like this arrow here. Okay, and here okay, three terminal PMOS like this. And if you see last four, This last four. Okay, here okay, generally we will use this one shorthand notation, NMOS enhancement mode device, and shorthand notation for NMOS depletion mode device. Here, here PMOS enhancement mode, depletion mode. Okay, okay. If you remember this last four, you can. Okay, that is enough. Okay, for PMOS, always this bubble is there. PMOS bubble. Okay, bubble is there. NMOS no bubble. Just okay, like this. And depletion mode, here thickness is there. See, thickness. Okay, here also depletion mode, thickness is there, and PMOS, okay, like this. Enhancement mode. These two are enhancement, these two are depletion, and here these two are NMOS, these two are PMOS. Okay, that is main difference. You need to know. Uh, Sharat, previous picture. Okay. Symbols or other one. Sure. Symbols. Okay, okay. Again, this file path is changing. Uh, 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 okay. Ground to source. Uh, okay, okay. Uh, okay. General ga. Okay. This is NMOS. Okay, na? Uh, okay. Here, this one is this is PMOS. Okay. This drain, so drain gate source. Here, drain. gate source. Okay, here okay, for depletion mode, okay, this is thickness will be like this. Enhancement mode only single line. Okay, this is one notation. And for other notation, okay, here only three terminals. Okay, in some notations, if we indicate uh, four terminal, that is if we indicate bulk. Okay, this is NMOS. NMOS. In NMOS, we will always connect ground. Okay, in PMOS, we will always connect high power supply or VDD. VDD. Okay, here drain, gate to source. Okay, for depletion mode, here thickness is like this. Okay, this line thickness is like this, depletion mode. And okay, in other notations, they will just simply they will use like this. Okay, uh, just bubble. This is PMOS. This is NMOS. Okay, this is advanced notation. Okay, generally they will use. Okay, generally, okay, they will prepare like this NMOS. This is PMOS. Okay, general notation like this one. Okay, this is P. This is NMOS. Okay, this is advanced notation. Okay, yeah, drain gate source, drain gate source. Okay, like this also they will indicate. Okay, this is NMOS. This is PMOS. Okay, these are main notations. Um, Next I will show mass structure. Hmm. Here, if you see here, okay, this is the okay just structure. Okay, this is P-type substrate, or you can call it as a bulk substrate. Okay, this is connected always source terminal or ground. Okay, uh, you see, okay, this whole thing is the P-type substrate or P-type semiconductor bar. Okay, indicating P-type substrate. And here, okay, this is called the drain. This is called the source. Okay, source diffusion and drain diffusion. Okay, using the diffusion process. Okay, using the diffusion process. Okay, means diffusion means at high temperature. Okay, this source material and drain material are okay deposited on this area. At high temperature, this material is diffused into the p-type p-type substrate. Okay, based on the temperature, okay, and thickness. Okay, this length will be diffused into the p-type substrate. Okay, this region indicate the depletion region. Okay, depletion region means okay in that region, uh, okay that region, uh, some charge carriers are present, means interface between the this substrate and this diffusions source and drain. Okay, and after that, uh, okay, after that we will deposit a oxide layer. Okay, this is called as a silicon dioxide. Okay, just I will indicate this is the source, this is the gate, this is the drain. Okay, this uh, this is the substrate, total substrate. Okay, using this semiconductor bar, diffusing the source and drain. First we will diffuse, will make source and drain. After that, gate. Okay, gate is deposited. Before gate deposition, this material. Okay, before that, this insulation layer is needed to deposit the gate. Okay, this is insulation layer. Insulation layer, that is oxide layer or silicon dioxide layer. Okay, after that we will deposit gate. Okay, gate. Okay, that material is called polysilicon. Okay, we will use gate connection for polysilicon, and after that you will use metal for connection here. Okay, this is metal connection. This connection is called metal. Here also drain. Okay, this is metal connection. Here also metal connection, and this substrate is connected to source. Okay, this is for the NMOS, enhancement mode MOSFET. Okay, the enhancement mode MOSFET, here channel is absent. Generally channel is not present. Okay, based on the apply voltage, generally we will use VGS. Okay, VGS greater than threshold voltage means VGS at a particular voltage. VGS means we will apply here some voltage. Okay, gate to source terminal. This is gate, this is source. Okay, we will apply gate to source voltage, and okay, here p type volts are here majority carriers. Okay, volts are majority carriers, and here gate to source voltage always you will apply negative voltage. Okay, because of this negative voltage. Okay, here are negative electrons at gate, and here positive. Okay, p type substrate positive. Okay, to control the gate to source voltage, okay, we will use negative voltage. Okay, to turn on this NMOSFET, okay, we will apply 1 volt or zero point 0.5 volt in the gate to source voltage. Okay, if you apply zero point 0.5 volts, okay, here because of this positive ions here at the gate, and here electrons in the p type substrate, these electrons are attracted toward this insulation layer. Okay, because of this applied voltage at gate to source voltage, here electrons are formed across the this insulation layer. And if we and again if we also apply drain to source voltage VDS means here if we apply VDS further, then electron flow will flow from source to drain. Like this, electron will flow. Here, a channel is formed. Here, channel is formed. Electron will flow from here source to drain, and we will get current in the okay here drain. We will get current in the drain. Okay, this is for the NMOS enhancement mode MOSFET. Okay, here channel is okay N channel. Okay, your channel is N channel means okay this is N type material, this is also N type material. Okay, when we apply gate to source voltage, your electrons at here insulation okay will flow from source to drain. Okay, channel is formed here. Okay, that's why we are calling it as a N channel MOSFET or NMOS enhancement mode MOSFET. Okay, here channel is enhanced when okay at particular gate to source voltage, at particular gate to source voltage only channel is formed and electron flow from source to drain, then drain current will appear at drain id. And here okay this length is called the channel length. Okay, here and here this length is called the channel length. And this one to this one is called the channel width. Okay, channel width, this is channel length. Okay, and for NMOS enhancement mode MOSFET we will use P-type substrate. Okay, for PMOS enhancement mode MOSFET we will use okay N substrate. Okay, are you understanding? For NMOS we will use P substrate. For PMOS N substrate you will use. Okay, just we will see PMOS. Just overview. Yeah. Okay, here also same. Okay, this is not PMOS, this is NMOS, but this is depletion mode MOSFET. Okay, depletion mode. In the depletion mode, MOS transistor channel is always present. In the enhancement mode MOSFET, channel is absent. Okay, upon the okay applied gate to source voltage, channel is formed in the enhancement mode MOSFET. But in the depletion mode MOSFET, channel is always present. Okay, this your gap indicate the not this gap. This is the channel. Okay, that is the channel. Okay, okay. Even when gate to source voltage is 0 volts, also channel is present, always present in the depletion mode MOSFET. And here operation also same. Okay, here drain, gate, source. Okay, here P-type substrate. Okay, here P-type substrate. So here diffusions must be N. Okay, means N type semiconductor. Okay, here doping means diffusing the N type material at particular temperature. Okay, this one is indicate the depleted area interface. Okay, when we apply gate to source voltage, some threshold voltage, suppose VGS greater than threshold voltage, here electrons flow from the channel source to drain. Okay, we will get current at the output terminal ID. Okay, here current flowing from drain to source and electrons flow from source to drain. Here current, electron current and this normal electron flow and current flow is reverse. Okay, this is depletion and diffusion. Here metal contact. Okay, you can also call it as a ohmic contact. Okay, this is oxide layer. Okay, now time is going to end. Okay, we will stop here. Okay, next we will see for different conditions how this channel is changing. Okay, different VGS, these conditions, cutoff, saturation, and linear, these conditions, how channel is changing. Okay, then we will see the fabrication of MOSFET process steps. Huh? Okay. Huh? Thank you. Thank you. Ah, thank you. Sri Lanka. అవును.